right, welcome Algebra 3 for Honors. On 1.6, let's get off to a great start for this next unit. So this first topic is solving rational equations. Rational equation is basically a bunch of fractions, polynomials on top, polynomials on the bottom, and its equation we're going to solve for x, but these are the steps. This is how you're going to do it. First, we're going to write all terms with common denominator. In order to do that, sometimes you're going to have to factor the denominators to find out, which factors are missing from certain denominators. After you've done that, set numerators equal to each other, because if all the denominators are the same, then you can just set the numerators equal and solve. And that's how you're going to find your possible solutions for x. But with rational equations, you got to be careful, because sometimes the solution that you get will cause you to divide by 0, which isn't allowed. So that solution wouldn't be valid. So check to make sure that it doesn't get 0 or in the denominator or divide by 0. If it does, you're gonna consider it extraneous and not a valid solution. Sometimes you'll get multiple solutions and some of them work, or maybe all of them work, or maybe none of them work. You got to check every single one to make sure that it doesn't cause division by 0. Okay. So you got these steps down, and let's try a couple. All right. So let's try. X minus 1 over 3 minus 2x over x minus 1 equals x. All right, so this is what rational expression is. Fraction, polynomial on top and bottom. Fraction, polynomial on top and bottom. We need to make all the denominators look the same. These are two completely different factors. They don't have anything in common. We have a denominator of 3. We have a denominator of x minus 1. So we're going to look at this one, and we're going to see what factor does this one need that this one has. Well, it needs a 3. So we're going to multiply by 3 over 3, which we're allowed to do because that's equal to 1, and we didn't change the value of anything. Now we're going to look at this one here. What does this one need that this one has? Looks like it needs an x minus 1. So we're going to multiply by x minus 1 over x minus 1. Again, we're allowed to do that because we're multiplying by 1. Now these two have a common denominator, but we need this one to have a common denominator as well. And it needs two things at the denominator, because right now all it has is over 1. So it's going to need a 3 times x minus 1 over 3 times x minus 1. Now look at our denominators. All of them are 3 times x minus 1. 3 times x minus 1. 3 times x minus 1. So for the moment, we can kind of just ignore the denominators. We are going to visit them at the end to make sure that whatever we get doesn't cause division by 0, because if it does, that solution is not valid. So now we can just focus on the numerator. Let's clean that up. So we're going to distribute here, right? X times 3x is 3x squared. X times negative 1 is negative x. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is plus 1. Careful here, it's minus. We're going to multiply negative 2x times 3. So that's going to be minus 6x. And here, I have an x times 3, which I'm going to distribute to the x minus 1. So that's going to equal 3x squared minus 3x. All right, so now we're going to solve. Let's clean up the left side by combining like terms. Now we get, let's see, I have a 3x squared. Now I'm going to combine my x terms. Negative x minus 3x is negative 4x. Minus 6x is minus 10x plus 1 equals 3x squared minus 3x. All right, so now it looks quadratic, but all those x squareds are going to eliminate, because when I subtract 3x squared from both sides, they all go away. That's nice because it makes it an easier equation, because now it's just a linear equation, which is easier to solve. Now let's get all the x's to one side. How about if I add 10x, and I get 1 equals 7x. And then if I divide by 7, I get x equals 1 over 7. And so what we need to do is we need to check and make sure that 1 over 7 doesn't cause 0 in the denominator. Well, the only possible way to get 0, you only have to check one of the denominators because they're all the same, right? So 1/7 minus 1 is not going to be 0. The only number that would not be allowed to be a solution in this particular example would be 1, right? 1 would make 0. So this solution of 1/7 is just fine. Let's try another one. Okay, this next one, x over x minus 2 equals 2 over x minus 2 plus 2. All right. So this is a denominator of x minus 2. This is a denominator of x minus 2. This one needs a denominator of x minus 2 to make them all the same. So if I did x minus 2 over x minus 2, now all my denominators are the same. Now, all I need to do is focus on the numerator. I can, temporarily disregard these. We are going to visit it at the end to make sure that we don't get 0 in the denominator with our solution. So I have x equals 2 plus 2x minus 4, right? Let's see here. Let me move this x to the left side, this 2x. So I have minus 2x and minus 2x, and I get negative x equals, I'm going to combine the 2 minus 4, negative 2, and if negative x equals negative 2, x equals 2. We did everything right. Let's check and see if this solution is valid. So if I were to plug 2 in for x into this denominator, I would get 2 minus 2. Therefore, it's extraneous, and it won't work. The only solution we could find, 2, won't work. So if in that case, we're going to say no solution. Okay? Because x equals 2, it doesn't work. All right? All right. Let's step up the rigor just a little bit. This next one's pretty interesting, because what you're going to find is that when we set the numerators equal to each other, we're going to end up with a quadratic equation. So we're going to have two possible solutions. All right. Here we go. We have 3x plus 2 over x minus 2 plus 1 over x equals negative 2 over x squared minus 2x. Okay. So, if you remember from the steps, and we didn't really have to do this step in the first 2 examples, but from the steps, it says, sometimes we need to factor this denominator to see what the other factors are missing. So this is factored and this is factored, but this is not factored. I can factor this denominator here with GCF. That's what I'm going to do. I'm going to pull out an x, and by doing this, we'll have x times x minus 2. And when it's in the factored form, it's easier to see, like, what does this one need? It has an x minus 2, so it just needs an x. So I'm going to multiply this one by x over x, which I'm allowed to do because that's 1. What does this one need? It needs an x minus 2. So I multiply by x minus 2 over x minus 2. Because that's 1, I'm allowed to do that. Now, if you look at every single one of the denominators, they're exactly the same, x times x minus 2. So we can just focus on the numerators. So So I'm going to distribute this x to here and to here, and I would get 3x squared plus 2x plus, if I distribute the 1, I get x minus 2 equals negative 2. Okay, look, this is going to be a quadratic equation, and if you remember from the last unit, quadratic equations, we need to have 0 on one side. So let's add, well, I guess we could combine these like terms first. So 3x squared plus 3x minus 2 equals negative 2. So then I'm going to add 2 to both sides, and I get 3x squared plus 3x equals 0. All right, quadratic, but it's factorable. Very simple factoring there too. We can factor out an x. Remember, if it's factorable, we can set each factor equal to 0 and solve for each factor instead of the quadratic formula or completing the square. It's a much easier, simpler case. I can factor a 3x out of both of these terms. I'm going to write that right here. 3x times, and if I factor 3x out of 3x squared, I'm left with x plus 3. Okay? Equals 0. Now I'm going to set this factor, 3x equal to 0. If I divide by 3, I get x equals 0 as one of my solutions. And this factor, x plus 3, if I do x plus 3 equals 0, that's the bell for 0 hours, early in the morning, 6:30. And I subtract 3, I get x equals negative 3. All right, now we have to check to see, maybe both of these work, maybe none of them work, maybe only one of them works. So if x equals 0, let's check. Well, if I replace this x with 0, that becomes 0, and 0 times whatever this is going to be 0. And we get 0 in the denominator. It's not allowed. So x equals 0 is a solution that's extraneous and it's not valid. I love it when there's two solutions. That makes me happy, but hopefully there's at least one. Negative 3. Negative 3 minus 2 is negative 5. Negative 5 times 3 times negative 3 is 15. Well, 15 is fine in the denominator. The only number that's not okay is 0 in the denominator. So in this case, there was one valid, there's the bell again. There was one valid solution for x, and it was negative 3. Okay? All right, let's do one more for good measure. Hold on. Made a mistake and I just caught it. I'm so embarrassed. I'm so sorry. I'm going to go back to here. I do apologize. When we factor 3 out, you're probably watching that. There is a 3 coming out and an x, and then I'm left with x plus 1. I forgot to factor the 3 out of that 3, and I'm so sorry. Hopefully you're not mad at me. So, and I don't want to restart the video for that. We fixed it. So 3x equals 0, and x plus 1 equals 0. So this one gives me a solution x equals 0. 0, remember, causes 0 in the denominator, so that one's not valid. If I subtract 1, x equals negative 1. Negative 1 does not cause 0 in the denominator. I would get negative 3 times negative 1, which is 3, so that's allowed. That solution checks out. Our one solution is x equals negative 1. All right, one more for good measure. Let's do negative 4x over x minus 1 plus 4 over x plus 1 equals negative 8 over x squared minus 1. Now, so this is factored, we need to factor this one. How about difference of squares to factor x squared minus 1? That would factor to x plus 1, x minus 1. So I want you to notice that this factored to these other two. That's a common thing. It happens a lot. If we don't, the problems get really messy. I mean, they won't always, but now, if you look, the only thing that this one needs is an x minus 1. Okay, and then the only thing that this one needs is an x plus 1. All right, cool. Now all the denominators are the same. Let's take a look. What answers would not be allowed in this problem? We wouldn't have negative 1 would not work because that would make this factor 0, and 0 times that would be 0. 1 would not work because that would make this factor 0, and 0 times that would be 0. So our answers, we know we can't have negative 1 or 1. Let's see what we get. I'm going to distribute the negative 4x, so I would get negative 4x squared minus 4x plus 4x minus 4 equals negative 8. I've got a quadratic equation again. And I don't really like that my a term's negative. I'm probably going to do something about that. So let's try, let's combine these. Negative 4x squared and 4x, they cancel. That's nice. That's going to be helpful. Let's go ahead and add the 8 over. And I get negative 4x squared plus 4 equals 0. You know what I'm going to do here? This is going to be a simpler one because there's no x term. It's going to be easier to factor. But I'm going to divide everything by negative 4 because that's going to simplify it and it's going to make my x squared term positive. And we're allowed to divide everything on both sides by the same number. So if I divide by negative 4, divide by negative 4, divide by negative 4, I get x squared minus 1 equals 0. And look how easy this one is to factor. Using difference of squares, I would get, I'll write it right here, x plus 1 times x minus 1 equals 0. Now from this factor, a solution that we would get is x equals negative 1. From this factor, a solution that we would get is x equals 1. But look at that. We have solutions of 1 and negative 1, and isn't that ironic? Because those are the only two numbers that we're not allowed to use as solutions. Those are the only two numbers that would make 0 in the denominator. What a clever problem. So since both solutions are extraneous, we're going to say no solution. All right. I hope you enjoyed that. I have some math Excel for you to practice, and good luck on that.